Ever wondered why your car's speedometer indicates an average speed? Or why a continuous function always has a point where the tangent is parallel to the secant? These aren't just random facts. They're derived from the foundational principles of calculus, the mean value theorem and Rolle's theorem. First, let's delve into the mean value theorem, a cornerstone of differential calculus. The theorem states that for a given function, continuous on an interval and differentiable on an open interval, there exists at least one point where the derivative equals the average rate of change over the interval. Imagine a road trip. You start at point A and after a while you reach point B. The mean value theorem guarantees that at some point during your journey, your speed equals the average speed for the entire trip. Next, we have Rolle's theorem, a special case of the mean value theorem. It stipulates that for a function continuous on a closed interval and differentiable on an open interval, if the function's values at the endpoints of the interval are equal, there exists at least one point in the interval where the derivative is zero. Picture a roller coaster ride. You start at a certain height, drop down, and then climb back up to the original height. Rolle's theorem ensures that there is a point in your ride where your speed is momentarily zero as you switch from going down to climbing back up. However, calculus isn't just about differentiating functions, but also integrating them. This is where the integration by substitution method comes into play. It simplifies the process of finding the integral of a function by replacing a part of the original function with a substitute variable. Think of it like preparing a complex dish. Instead of dealing with all the ingredients at once, you prepare them one at a time, making the overall process simpler and more manageable. To summarize, the mean value theorem and Rolle's theorem are fundamental principles of differential calculus. They provide guarantees about the behavior of a function over an interval. The mean value theorem assures that there's a point where the derivative equals the average rate of change, while Rolle's theorem guarantees a point where the derivative is zero. On the other hand, integration by substitution is a valuable tool in integral calculus. It simplifies complex integrals by breaking them down into more manageable parts, much like preparing a complicated dish one ingredient at a time. So, the next time you look at your car's speedometer or ride a roller coaster, remember the mean value theorem and Rolle's theorem. And when you encounter a complex integral, don't forget the method of integration by substitution. Understanding these principles can provide a deeper insight into the world of calculus and beyond.